All right, now we're going to do a bunch of conversions with polar coordinates. So polar coordinates to the xy plane and the xy plane to the r theta plane or the polar plane. So just to remind you, these are our rules for special right triangles. And then let's get some of the really important conversion equations, which we all know already. So remember, if we have a point on the unit circle, so if you imagine this being a circle, okay, then I know that the y coordinate is equal to r sine theta. The x coordinate is equal to the radius times the cosine of theta. And then r is equal to, or we can say r squared is equal to x squared plus y squared. So if I have x squared plus y squared, I can rewrite that as r squared. For theta, I know that the tangent of theta is equal to y over x. So our four really important equations are this, 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 and this. Okay, we're going to keep those in our back pocket while we're doing our conversions for the rest of the examples here. Okay, so we're going to convert to polar coordinates, or from polar coordinates to rectangular coordinates. So from in terms of r and theta to in terms of x and y. The 5 is the r, the 45 is the theta. So how do I change this point into an x comma y point? So how does this equal an x comma y point? So let's just sketch it out really quick. 45 is about right here. Okay, so theta is equal to 45, and then the radius is equal to 5. So what I want to know is, what is this x comma y that gets me to that terminal point? Okay, so what I remember is that, x is equal to r cosine theta, and y is equal to r sine theta. So, and I know what r is, and I know what theta is, so I can just plug them in. I'm going to write this as an ordered pair. So our x is equal to r cosine theta, and y is equal to r sine theta. So this would be 5 times the cosine of 45 degrees. This is 5 times the sine of 45 degrees. So I get 5 times root 2 over 2, comma 5 root 2 over 2. And that's my x and my y coordinate. So let's do B really quickly. Go ahead and graph B, because I think it's helpful to see where it is. So you're facing pi, so we're going to face that way. And I'm going to go back -3. So 1, 2, 3. I'm actually going to go towards 0. So my point is right here. And on the xy plane, well, this one's easy. This would be 3, 0. So let's go ahead and calculate this out. I can use my r. So this is my r and my theta. So r cosine theta times r, or comma r sine theta. So I get -3 times the cosine of pi and -3 times the sine of pi. The sine of pi is 0. So, no, just kidding. The sine of pi, the sine of pi is 0. So this is 0. The cosine of pi is -1. So -3 times -1 is 3. And we're converted. we're going to convert the other way. So x comma y to r comma theta. Okay, so again, let's just graph these in a little sketch. 1, 2, 3, 4. 1, 2, 3. Okay, so I'm moving over 4 and up 3. So negative 4 and 3. I need to know what, this is an x and a y. I need to know what r and theta are. Okay, so how would I figure out what r and theta are? Well, I need to know what this angle is. I need to know what that angle is and what the radius or the magnitude of this length is. So, well, I think for the length, we can use a Pythagorean theorem. So r squared is equal to x squared plus y squared. So r squared is equal to 3 squared plus negative 4 squared. So r squared is equal to 9 plus 16. R squared is equal to 25. Root both sides. So r is equal to 5, positive 5. And we knew that because it's a 3, 4, 5 triangle. Okay. So we're going to hold on to this for later. Now we need to figure out theta. So I remember that I can use the tangent of theta is equal to y over x, just like we did for vectors. Okay, so tangent of theta is equal to 3 over negative 4. So tan inverse of negative 3 over 4 is equal to theta. Okay, so theta is equal to negative, in degrees, it's negative 36.89 degrees, but this is the fourth quadrant, and we need to get into the second quadrant, so we're going to add 180 degrees, which gives us 143.13 degrees. So our r comma theta would be 5 comma 143.13 degrees. All right, let's do this next one. Okay, so I'm going to sketch it over here. We're a little tight on space. So 1, 2, 3, 1, 2, 3, 5. So positive 3, negative 5. Looks like we're in the fourth quadrant. So that's going to make some of this a little easier. That's going to make our tangent a little nicer, huh? Okay, so go ahead and solve for r and theta, and then we'll check in with you. So r squared is equal to x squared plus y squared. So r squared is equal to 3 squared plus negative 5 squared. So r squared is equal to 34, and we'll go ahead and root that. So r is equal to square root 34. And then the tan inverse of y over x, so negative 5 over 3, is equal to theta. And theta is equal to negative 59.04 degrees. You can leave it like that if you want, or you can add 360 degrees if you feel like giving it a full rotation, which gives us 300.96 degrees. Okay, so our point in polar form is 34, 300.96 degrees. So these are just a different way to write a point on the XY plane. And we're going to have one more video after this. Yeah, one more.